This is Brad Wilson. Come on up, Brad.
Thank you, thank you, thank you. Hello, everyone. Thank you for joining. So as Karen said, we're going to talk about dynamically create route-driven hierarchical network maps with bitB. I'm Brad Wilson, CEO and founder of QoS Networking, and I'm also the creator of bitB, and I am Brad in the box. Okay. So what we know is network maps are critical. Topology maps are critical. Drawings are critical. But, Houston, we have a problem. They are seldom drawn the way that they should be drawn. That is the problem with network maps. There's 3 reasons that we find that this is happening. Network drawing skills are not taught. Network drawings are not maintained, and there's no standards for network drawings. So, let's see how bitB addresses these issues. We'll take them one by one. Okay, network drawing skills are not taught. Many times someone's handed Visio and they're told, okay, create a network drawing, and you say, yeah, right, okay? So it's not that easy to create a network drawing, and then it's out of date very soon after you created that drawing. So what bitB does, it auto-discovers your network. It uses the same process you use. It runs show commands. You give it a username and password, you give it one IP address, it's going to go out and discover your network, okay, automatically. Once it gets the information, it's going to pull it back and dynamically create maps for you. So you could have gone out, gone to lunch, got a coffee, whatever you want to do. When you come back, you got some maps. We apply successful topology types. There are different drawings that you should draw specifically for that environment. For example, a physical, a logical, and what we call a V-physical. That's how bitB will actually teach you. It'll teach you because you will now see drawings the way the drawing should be seen. Too many drawings out there don't look like they should, and they don't help you that much. So let's see what bitB can do here. The second problem, network drawings are not maintained. Just as I said, if you're using Visio, and we've been here all day yesterday and today, people come to our booth and they're like, I say, what do you use to dynamically map your network? I use Visio. Okay, Visio is not dynamic, all right? So we want to save you some time with bitB. We definitely are going to do that because we pull devices every 5 minutes. They're automatically updated with running configs, interface stats, IP route information, everything. It's the same stuff you would do, but it's done automatically for you. Third problem, no standards. I've seen a lot of drawings over the years, and trust me, there are no standards. There's no book out to say how to create a network drawing, right? bitB is going to show you how to do that. We actually have patent pending technology for our map layouts, which are hierarchical, route-driven. We have 3 topology types, physical, V-physical, and logical. So you've probably heard of physical and logical. We're going to talk about the V-physical today. All right. It's a little humorous slide here, but I have to put it up. This is a thing you do not want to do, but it's done all the time. Someone thinks it's a great idea to create the physiological drawing. The physiological drawing is when someone tries to take a physical drawing and a logical drawing and put those together. That's not how you create drawings. Why is that? Well, if I do a physiological, I can't tell what the devices are doing. Are they switching? Are they routing? I don't know because I can't tell from the drawing. Just say no to V-physical, please. Leave it in the medical field. It's not in the networking field, okay, please. Okay, this is what bitB does. We create hierarchical route-driven maps. We have hierarchical network maps. You see the whole network. No one's told you out there to look at the small picture. We don't look at the small picture. We look at the big picture. We look at the whole network. We have different ways that you can actually display the drawings, top, down, left, right, however you want to see it. But the really awesome thing, they are route-driven. Our maps, when they're put together, are following the routing tables in your devices, and we create this hierarchical route map, as you will see in the next slides. So let's go through the 3 topology types, okay? The 3 topology types of physical. On the physical, you're going to see layer 2 switch, and you're going to see VLANs for all the devices. You're going to see layer 2 and layer 3 devices, but you're only seeing those at the layer 2 level. Also, devices will only appear once, and you're probably thinking, well, why would a device appear more than once? Well, as you see the next couple slides, you'll see why that is. So let's just look at it for now. 1 set of ASAs, 1 set of 7Ks. Next slide. The V-physical. This is new probably to everyone. We call it the virtual physical. You need to have a drawing that will show you the virtualization of a physical device. This shows you that. So again, we're still doing layer 2 switching. We're still doing layer 2 and layer 3 devices. But now I've created another device instance and another object on the map of that device instance. So if it's a security context or it's a VDC, we're going to show that to you. So now you actually see 2 sets of 7Ks because we virtualized it for the VDC. I see 2 sets of firewalls because we virtualized it for the security context. This is how the packets go through your drawing. That's how we show them. We also have physical device grouping, which we put containers around to show you which VDC that is. Okay, next. The logical, one of my favorites. Logical is layer 3 routing. Subnets, now I'm seeing all layer 3 devices, no more layer 2 devices on this. That's that part of when someone wanted to do that physiological, don't do it. Because on the logical, it should only be layer 3 devices showing layer 3 information. Subnets, interface IPs. The other thing that you're going to see here, we now have the physical breakout. So we could see virtual physical. We call it the V-physical. We also have the logical breakout, which we call V-logical. Why? Because you have VRFs. When you have VRFs, you've got to see these in a virtualized environment. You want to see how the packet actually moves through the network. Okay. We have a lot of other great options inside of bitB. Okay, not only did we show you the VDCs to show you the security context and also to show you device context, we did the V-logical to show you VRFs so that you can see how the packets are routing through your network. We also have dynamic data grids. So basically you can get all this information that was used to create your maps, you can see it in a dynamic data grid. You also have the show command files. Everything we use for a show command file, you can pull those up and view those also. Okay. Create maps from the past. The great thing about creating maps from the past, I can go back to any 5-minute interval for all the data that you pulled and create a map. So if you've been pulling this for a year, I could pick a 5-minute time frame over the year and actually show you that drawing. Huge. Advanced device lists just let you get more granular about what you're showing on the drawing. And the one thing I didn't talk about that's totally, totally awesome, simple export to Visio. For all those people out there doing manual Visios, stop doing manual Visios. Let bitB create your drawing and export that to Visio for you whenever you need it. View and print the drawings. They're great for design sessions, network change preparation. Okay. What's our roadmap? It's simple. We're going to do mapping, but we're also going to create a change assistant, some other options. So if you're interested in these options here, stop by booth 1925N and we'll go over the roadmap with you. Okay. In closing here, as we said, there's backpacks that everybody gets for attending this. You'll also be entered into the raffle. We do a daily raffle for a battery pack, wireless battery pack. We also do a drawing at the end of the show for a Yoga C930 laptop. Pretty cool for attending this session. Thank you, everyone. Appreciate it.
Thank you, Brad. Thank you. Hey, we've got a little time here. Does anybody have a question for Brad? Raise your hand, and I can come around with a microphone. Anybody have it? Right over here. Nice and loud into the mic.
Is there any kind of historical where you could use it for troubleshooting as well to see if anything's changed on any of the routes, that kind of stuff?
Yes, so basically, as I said with the 5-minute, we pull every 5 minutes. You could pick a 5-minute interval, go back to that, and actually compare the drawing. It's a side-by-side right now, but you can do it.
Anything?
Oh, yeah.
Back?
Oh, definitely. So it pulls every 5 minutes. If you ran this for a whole year, you would have every 5-minute interval for that past year. You could pick any one of those. And you'll actually have all the show command files and everything. MAC addresses, ARP tables, everything.
Good question. Good question. Thanks for asking.
Yeah, great question.
Anybody else? Right here.
So when you pull those things, where do I get the data in a pattern? Where do those data, what kind of format would it just go kind of in the raw text file, or how would that work?
Okay, so what we do, we use the actual show commands that you would use to collect the same data, ARP caches, route tables, and everything. We parse the data, throw it into a database. But we also keep all the show command files, so you can pull up a simple file with every show command we ran, and it's in the regular show command format. Easily readable, easily searchable.
Good question. Back here.
For the V-physical, I saw VDCs. Do you do VSS and switch stacks? How do you present those?
The switch stacks would be shown as 1 because of the IP address being as 1 on the switch stacks. VSS, I'm trying to think on the VSS one, I believe that's also, you would see both switches on there for the VSS because they have an IP address, I believe you put on both of those. So wherever there's an SPI, you'd see it. So both devices.
Over here?
Is there any alerting notifications built in for IP conflicts or network issues?
Not yet. Okay, so we are new. We just released this week at Cisco Live. All right, we've been in beta for a while. We're running a good discount and everything, so come see us. But yeah, anything, we're looking for customers to give us feedback.
Congratulations. I didn't know you just launched.
We launched this week at Cisco Live. Yeah, 100%.
Fantastic.
Yep.
Any other questions for Brad? That's good conversation.
How well does it understand and visualize transparent firewalls?
I have not used it on a transparent firewall yet. But as long as bitB can actually SSH that device and pull the information, we'll show you as it connects to the switch. The problem is with the MAC addresses and IP addresses, so we'd have to look at that. But definitely work with us. We haven't run into it yet, though. The transparent firewalls. Great question.
Okay. Anyone else? Well, clearly, you've sparked some discussion here, which is fantastic.
I think so.
I think questions are always quite indicative, right?
Yes, definitely.
So if you want to take a deeper dive, you want to have a more of a conversation with Brad, head on over to 1925N. That's the bitB kiosk, 1925N, if you want to take a closer look. And it appears that some of you may want to. So how about another thank you to Brad Wilson. Thanks for joining us today.
Thank you. Thank you, everyone.
Thank you. Have a great day.
Thank you, Karen.
And thanks to all of you for joining us here in our Solutions Theater.